So section 4.1 is on congruent figures. So this whole chapter is going to be about congruent objects. So what do you guys think congruent figures would be without looking? Huh? Similar? Like the same shape, maybe? Do you think they have to be the same size? Yeah, so the same like segment lengths and then the same angle measurements as well. So congruent polygons have to be exactly the same. So if I took these two quadrilaterals here and I like rotated one on top of the other, they would be exactly the same. And sometimes you might have to flip it over, like do a reflection or something. So you need all of the sides to be congruent and all of the angles to be congruent. So the congruent statement is that quadrilateral A, B, C, D is congruent to the other quadrilateral. Okay, so let's kind of look at our segments. So I have A, B. What do you think that matches up with?
WX.
Yeah, WX, so this one. So let's do little congruence marks there. And then what do we think BC is? Same as XY. And then this one we'll put 3 marks. And this one we'll put 4 marks. Gets a little crazy once you have 4. Lots of little marks. So as I go around, if I go A to B to C to D, let's go around in the same order on the next one. So it's going to be W to X to Y to Z, right? Do you guys all see that? It's not necessarily in alphabetical order, but it is in this case. So that means that all the corresponding sides are going to match up and all the corresponding angles are going to match up. So let's start with the angles. That's the easy one. So whatever your first letter is, that should be the same angle measurement as the first letter of the next one. Okay, so A should be the same angle as W. So we're going to say that angle A is congruent to angle W. And then B is congruent to X, right? And then so on. So angle C is congruent to, so this was the third letter, so angle Y. And angle D is congruent to angle Z. All right, so you can see those in the picture. Sometimes it gets a little crazy once you have 3 swoops. So let's do like a swoop with a line on it. Like that will be the last one. All right, so then the letters match up as well. So you can go in any order here. So let's say that I just talked about randomly I picked this letter and this letter B. Well, not BD, that's actually a diagonal. What if I picked BC together? What do you think that segment's going to match up with on the next one? So don't look at the picture, just look at the letters in here. So BC is going to match up with XY. Okay, so we're very, very particular about this in geometry. So if you say B and then C in that order, you need to say X and then Y in that order. Okay, so looking at your original congruent statement, you're looking for the order of the letters. Okay, so pretty easy on this one because they are in alphabetical order. So I would say AB is congruent to first and second letter WX. And then I would say BC is congruent to XY. And then I would say CD is congruent to YZ. And then the last one, so going around, would be DA is congruent to ZW. So it doesn't matter what you do on the first one, but just make sure it matches up on the second one, right? If you did the first and second letter, then make sure you do the first and second letter on the second one. Does that make sense? Do you guys know what I'm talking about? Okay, so if you're given that a triangle, so usually with quadrilaterals we don't put a little symbol out front, but with triangles we do. So it says triangle XBD is congruent to triangle AML. List the 3 congruent sides and the 3 congruent angles. So let's start with the congruent angles. That's the easy one. So what 3 angles, 3 pairs of angles do we have? So we have angle X matches up with angle A, because again, first letter, first letter. We have angle B matches up with angle M, and we have angle D matches up with angle L. So those are the easy ones, the angles. Okay, so kind of test yourself. Think about the sides. So how about XB is congruent to angle, or not angle, to segment what? Got it. And then if I do BD, then it's going to be congruent to ML. So what's another one? So we did these two together, and we did these two together. What else do I need? You got it. XD is congruent to AL. Perfect. And then that's all three sets of sets. So I don't need to say, now that I have XB, I don't need to say BX, right? That's the same segment. So as long as you've done that once, you're good to go. Okay, does this make sense to everybody? It's pretty straightforward. All right, so the third angles theorem, this is a pretty obvious one in geometry, but if you have two angles in one triangle that is congruent to two angles in another, so if I had this was like 80 degrees and this was 30 degrees, and I knew this one was 80 degrees and 30 degrees, what do you think is true about that third angle? Yeah, they have to be the same. Doesn't that make sense? If you had like 80 and 30, that's going to be a total of 110, so that last one has to be 70 degrees. And if you have 80 and 30, well, that's 110, so the last one has to be 70 degrees, so same idea. So it doesn't matter what these measurements are, but if you have the congruence marks, then you know that that third one has to be congruent. Okay, so that's a pretty important theorem, so we're going to star that one. We should know the name of that for sure. Oh, my picture got taken down here. I don't know why. Okay, so it says find the value of the missing angles using the third angles theorem. Okay, so we have congruence marks in part A, and we actually have the congruence marks in the same triangle, right? We have those two marked. So that means we have an isosceles triangle. So we have 35 degrees here as well, which means these two sides would be congruent. That's called the isosceles base angles theorem, so we'll talk about that a lot. So if I have 35 and 35, that's 70. So how much is left for that top angle? 110, right? Now we know in the next triangle that these two angles are the same, right? And we actually know that they're the same as the original triangle because they have the same markings. Okay, so these are both 35 and 35. So then the last angle then is 110. Okay, so since it had exactly the same markings. If you had, you know, something that had two markings, we wouldn't be able to say that the. All right, so B. So we have 30 and 102, so they add to be 132. Yeah, so we have 48 left. Well, that looks good over here, right? Because I have 48 and 102, so what's the last one? 30, right? All right, so it says use a paragraph proof to explain why ABC is congruent to EDC. So far, in order to say that these triangles are congruent, we need to say that every single side is the same and every single angle is the same. Okay, there's going to be some shortcuts that we're going to learn later in this chapter. But right now, that's all we know. So we have to get every single side is the same, every single angle is the same. Okay, so let's start with the 58. So this thing's marked in red. Isn't the one across from it also 58? So when we write that in, so whatever we write in, we're going to put in our paragraph proof, okay? So we can say we were given that angle, so let me put measure. So the measure of angle ACB was equal to 58. We can just say measure of angle B is 75. We don't have to put 3 marks for that one. Do you guys see why we can just call it measure of angle B? That's the only one that's angle B right there. And then we were given measure of angle E is equal to 47. And then we know that AB, that length is 10. Oops, if it's a length, I'm not going to put the segment mark over it, though. So I'm going to say AB is equal to 10, and then DE is equal to 10 as well. Okay, anything else that we were given just in the picture? How about some markings? How about AC is congruent to what? Yeah, AC, this one, is congruent to, let's call it EC. So let's go from the same, like if we were matching them up, if we put them right on top of each other. So let's say it's congruent to EC. And BC is congruent to DC. Do we see those? So we were given all those different things. So we're pretty much there. We only have a couple more things to say. So for our sides, we have 1 and 2 sets of sides. So we need one last side. Can we say those last sides are congruent? So AB is congruent to, let's look at our letters up here. AB is congruent to, what order do you think I want to say? Let's say ED. And why can we say that those are the same? Yeah, they're both 10, right? Because they're the same length, right? So let's say because AB is equal to DE, right, that had the same lengths. So that's our third one. Okay, now we need to work on the angles. So we know that angle ACB is congruent to angle, let's go in the same order. So if I did ACB, oops, 1, 3, 2, there. Oh man, sorry to make you dizzy. All right, so if I had 1, 3, 2, then I want to do 1, 3, 2 in that order as well. So I want to say ECD. Why are those two congruent to each other? What's the reason? So remember, we always have like statements and reasons, statements and reasons. Look at our picture. So ACB, this angle, why is it congruent to ECD, this angle? They are both 58 degrees, but what do we call it? Right, by vertical angles. All right, so that's our first angle thing that we have congruent. Okay, can we find some measurements? So the measure of angle A has to be what? 47. And the measure of angle D has to be 75. Why is that true? Why do we know those have to add up to be what they are? Because we know that triangles have a sum of 180. So do you guys remember what the name of that one is? Okay, that's the triangle angle sum theorem. We'll just call it triangle sum theorem. So by triangle sum theorem. All right, therefore, we know that angle A is congruent to angle E, and angle B is congruent to angle D because we had the same measurements, right? Because measure of angle A equals measure of angle E, and measure of angle B equals measure of angle D. All right, so we're almost there. So we have our 3 sides and our 3 angles. Therefore, triangle ABC is congruent to triangle EDC. So why do we know they're congruent? Because we found all 3 sides were congruent, all 3 pairs of sides were congruent, all 3 pairs of angles were congruent. Was that pretty long? Do we hope that maybe there's a shorter way of doing this? Yeah, there are. So there's lots of different ways. So we're going to use something called angle, side, angle, 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 side, 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 side. We're going to learn all these different things throughout this chapter. Okay? All right, so explain why triangle ABC is congruent to EDC. So I won't make you guys write out the whole proof here, but let's explain why these are congruent. So first of all, I have right angle marks. So do you guys know there's a Pythagorean triple, like 3, 4, and anybody know what that one would have to be? 5. Have you guys done that before? So let's find it. So if I have 3 squared added to 4 squared equals, we'll call that x for now, x squared. I get 9 plus 16 equals x squared. So I have 25 equals x squared. So when I take the square root of both sides, I get x equals 5. Okay, so this is called a Pythagorean triple. This is a common set of numbers, 3 numbers that when I square each one, it works in the Pythagorean theorem, right? 3 squared plus 4 squared equals 5 squared. Any multiple of those, like if I multiplied by 2 for each one, so 6, 8, and 10, that would also work. Or 9, 12, and 15. So math teachers like to use the 3, 4, 5 when we're coming up with triangles because we're like, oh, then we know this works in the Pythagorean triple. It's nice. It's nice numbers. Another Pythagorean triple would be 5, 12, 13. That's a common one as well. So like 10, 24, 26 would also work. Does that make sense? Okay, but a lot of things, when you use the Pythagorean theorem, you don't always get like nice whole numbers like that. That's why it's called a Pythagorean triple. These are nice whole numbers that work in that Pythagorean theorem. All right, so when you see a 3 and a 4, and those are the legs of a right triangle, you can automatically say, oh, that hypotenuse is going to be 5 then, if it's a right triangle. It doesn't work if it's like obtuse or anything, right? Okay, so both of these are 5. So we know that AC is equal to 5, and EC is equal to 5. So that means that AC is congruent to EC, so we're good there. Do we know our other ones? Yeah, we know that AB is congruent to ED, and BC is congruent to DC, because we'll just say same lengths, right? You guys get what that means. BC, because you could do B/C if you want. All right, so we have all 3 sides are congruent. And then do we think our angles would have to be congruent as well? Yeah, so by vertical angles, those inside angles are the same. So angle BCA is congruent to angle DCA, or DCE, by vertical angles. And let's just say all 3 pairs of angles are congruent. So therefore, triangle ABC is congruent to triangle EDC. Have you guys seen the 3 little dots? That means therefore. So therefore, triangle ABC is congruent to triangle EDC. Okay, does that make sense? Kind of a rough proof. All right, so number 4 says use the statements and reasons proof. So this is typically why my students like the statements and reasons a lot better, because it's just like you have to write out all the words in between. You can just kind of state each thing. So statements and reasons, that's this type of proof. You've now appreciated statements and reason proofs. All right. So we're trying to prove that these are all congruent, but all 3 sides and all 3 angles are congruent. So let's see if we can do it. So a lot of things we were given, right? So let's write all the things we were given. So we were given that PQ is congruent to PS. So that was these markings. We were given that angle Q is congruent to angle S. QR is congruent to SR. So those 2 markings, and then this and this. And then one last thing. So we can't just call those angle P at the top. So we're going to say angle QPR is congruent to, my pen's not working very well. So QPR SPQ. Now notice I went in a certain order. So if I did Q first, do you see how that kind of matches up with S over here? That's why I did like QPR, and then I just started the S instead of the, like I could have started RPS, but I wanted to kind of match it up with what we had over here. Okay, so what's our reason for all that? Given, right? We like those. Did I mess it up? SP, oh yeah, thank you, SPR, thank you. All right, so what else do we need? So we have 2 sets of angles, right? So we need that last angle. So how can I say that angle QRP is congruent to angle, so QRP, SRP? How can I say those two angles are congruent? It's one we learned in this section. Let's go back. You guys see it? That's why we need to know that one by name. So it's by the third angles theorem. So if you have 2 angles are congruent already, we can say the third one's congruent by the third angles theorem. And you can abbreviate it, because that's how I write it usually, third angles theorem. So if we knew that 2 sets of angles were congruent in a triangle with another triangle, right, then we can say the third angles are congruent. So we have our 3 angles are congruent. and we have two sets of sides congruent, how can I say that this inside side is congruent to itself? So how can I say PR is congruent to PR? Yep, you got it, reflexive property. This would be property of congruence in this case. Okay. Sometimes I kind of shortcut this, and I mean, you can say reflexive property. I think that's technically the correct term here, but sometimes you'll see me write like same side or something like that. I'm cool with that if you write it's the same side. It's like a shared side. Does that make sense? It's like the same segment. Okay, and then the last one, 4. So what were we trying to prove? We were trying to prove that this was congruent to this one. So we're going to say triangle PQR is congruent to triangle PSR. So whatever it says, explain why this is true or prove that this is true. That's always your last step, your last statement. And our reason is, we'll say definition of congruent triangles. Because by definition, we said that we had to have all 3 sets of sides congruent, all 3 sets of angles congruent. Okay. All right, does this make sense?